How radiation is used for sterilization. How is radiation used to sterilize medical equipment? Gamma rays are high-energy electromagnetic waves. Therefore, they can only be stopped by thick lead. This means they can easily pass through medical equipment like syringes. If the syringe is kept in a sealed bag and gamma rays are passed through, they will eliminate all living tissue such as viruses and bacteria. This stops the bacteria from reproducing, multiplying and growing, which sterilizes the equipment. What methods are used to produce the radiation? The gamma radiation is emitted from radioisotopes, usually cobalt-60 or cesium-137. Use of radioisotopes requires shielding for the safety of the operators while in use and in storage, as these radioisotopes constantly are emitting gamma rays and cannot be turned off. With most designs, the radioisotope is lowered into a water-filled source storage pool. The water pool absorbs radiation to allow the maintenance personnel to enter the shield.
The source movement is controlled by a hydraulic cylinder working through two sets of stainless steel wire-rope systems. Two source lifting blocks are provided, one for smaller source frame and the other for the larger source frame.
Once treated, are the sterilized instruments radioactive? As the radiation that is used is gamma rays with no ionizing properties, the instruments do not contain radiation after the sterilization process. The equipment will obviously contain small amounts of radiation, but at a safe level. What advantages does radiation sterilization have compared to other techniques? And why are some products unable to be sterilized with certain methods? Ethylene oxide, a sterilization technique using the gas compound of ethylene and oxygen, must allow for gas movement and exposure to a range of pressures at an elevated temperature and a quarantine period of 8 to 24 hours, whereas radiation sterilization does not require any of these things. Electron beam sterilization only works with low-density products such as wires and cables, whereas radiation sterilization works with almost all medical equipment. Autoclave sterilization involves subjecting equipment to high-temperature steam. When autoclave sterilization is being used, there are many factors that you must take into account, such as the heat and/or moisture, that can be hazardous to the integrity of the product. In comparison, radiation sterilization does not affect the integrity of any equipment. Radiation sterilization is ideal for medical equipment, as it would not require a quarantine period and would not require the facility to purchase any more equipment to make up for the equipment being quarantined. What are the disadvantages of sterilization via chemical process? There are several disadvantages to using chemical sterilization, including the equipment must be totally immersed, the equipment must be able to withstand a temperature of 50 to 56 degrees centigrade, items must be sterilized relatively close to the intended time of use, items must be able to fit inside the sterilization containers and/or trays, and that the sterilant must make contact with all surfaces of the device. Another application for radiation is a process called crystal color enhancement that produces the color in topaz crystals. Uncolored, rough, preform or faceted topaz is subjected to irritation, which speeds up the natural process of coloration and results in gems with sky blue or similar colors. Topaz that would normally be discarded becomes commercially and aesthetically desirable. We also have some bonus content for your enjoyment.